I had to pick a day. I just picked a day, all
I
right?
just saw the sign. It's so random. It's August 3rd, 9:25 a.m.
Okay, let's get this done. Everyone did a great job, almost. So you have u equals sine here, and du is equal to cosine. And so this ends up being the integral, dx, sorry. So u cubed, and that's going to be u to the fourth, plus c. Oh no, someone forgot the plus c.
Oh, I forgot the C.
Half of you forgot it. I thought about
Okay, but in our defense, on Lumen, we don't
Yeah.
I know, it's annoying, it's annoying. Yeah, if you here, I'll omit the C,
Isn't
just
that to the fourth?
here, yeah, to the fourth, thank you. Thank you, fourth. And then this one, u is equal to secant, no, I blew it. Yeah, u is secant. This one's the one that took everyone forever, apparently. And then tangent, secant. Do I really need to write it out? No, I don't. This is going to be u squared du, because you're going to take the tangent, one of these secants, put them with the dx, and it'll become this. There's two secants left, which is why it's that. U cubed over 3 plus c. I'll leave this one off just to make you feel better. And then this is going to be secant cubed over 3. Put a box around it. Minus 1 because there's no plus c. There we go. But that's out of 100. You'll be fine. Yeah, I saw half of you didn't put the plus c's in. But yeah, it's Lumen. What's wrong with some of them? They require plus c. Remember? They had some antiderivatives where there were plus c's. Anyway, yeah, let's go on to this new stuff. We could drag this out, though, and it could take 2 or 3 days, and then it'll be fine. And then we won't have any more new stuff. So it's up to you. So ask lots of questions. Okay, so integration by parts is what we're going to do today. And why do we need integration by parts? It's because of something like this. Take a look at this thing. How are we going to do this antiderivative, x times e to the x? Well, one option is to use substitution, right? Well, what are we going to substitute for? So if we use substitution, I don't know, we could let let's try u equals x, du equals dx. That means we have this, u e to the u du. Well, that doesn't really help us, does it? We're really not fixing anything. So that didn't work. Let's try letting u equal e to the x, then du is equal to the e to the x dx. So what in the world, what is this? That's going to be the integral of, I don't even know what to do with this. The x, I guess I could do this little trick where x is the natural log of x. So this is the integral of u. Natural log of u, du. Yeah, I don't even know what to do with that now, because I don't know the antiderivative of natural log of u. Okay, I fibbed. I do know the antiderivative of natural log of u. But the reason I know the antiderivative of natural log of u is because I know how to do this new method. And that's the only way to do this. So what do? Well, we give up. No, we don't give up. We go back in time and we remember the product rule. Do you remember the product rule? I'll bet you do. In fact, I know you do, because it's going to be, so this is where the review comes in. You were complaining that we're not doing review? Here's some review. So let us do some review here. Give me a sec. Find this. So write down what you think the product rule is. Whoop. I'll make it big so we can all see it and enjoy it. So what is the product rule? I'll give you a minute, and I'll pick a rando to tell me the answer. Okay, so Ethan, you know the answer to this. What is the product rule? That is perfect. Plus, you said g prime of x? Okay, f of x. Very nice. Okay, so you might wonder, why do I care about the product rule? Well, it's because this thing that I just showed you a minute ago, this thing looks like a product. In fact, it is a product. And so you're tempted to say, I'm going to use the product rule. And if you said that about this, you're correct. The only trouble with that is that we have to sort of disentangle the product rule and figure out where we started. Like what were the starting f and g to give you this as its derivative. So that's where the difficulty lies, and that's why this is somewhat difficult, but it's not that hard, to be honest. So one thing I'm going to do, though, is I'm going to rewrite that product rule that you have here just slightly. There's nothing wrong with Ethan's answer, and you probably have something similar, but I'm going to rewrite it like this. I'm going to rewrite it as g of x times f prime of x plus f of x times g prime of x. I know this is a very subtle difference here, but it'll hopefully help us out. Now that I have this, I'm also going to, so you'll notice that you have this thing on the left, this stuff on the right. I'm going to rewrite this by multiplying both sides by dx. So you have g of x, f prime of x, times dx plus f of x, g prime of x, dx. And that may feel funny to you, but we're actually employing the chain rule there, so it's sort of algebra, kind of. But anyway, and then of course what we were going to do now is just integrate everything. What in the world did I do here? Oh, I know what I did. I left off this d right here. So that means the derivative of a sort. Okay, so if we integrate everything, the fundamental theorem of calculus says that the integral of a derivative is just the thing here, and then you have this integral and this integral. Okay, so pick one. I don't care which one. One of those is going to be the target integral, and that's going to take the place of this. And then the other one is going to get moved to the other side of the equation. Now, to standardize things, here's how we're going to do this. Because, you know, all of these f's and g's, it's kind of hard to figure out which one of these functions is f and which is g. And so back here, instead of thinking in terms of f and g, we're already used to thinking in terms of substitutions. So what we're going to do, instead of using f and g, is we're going to use u and v. So we'll have a u and we'll have a v. Now I know you're thinking, why did you put the u up there and the v down there? Well, there's a good reason that we'll show in just a minute, but I'll tell you exactly what the u and the v are going to be. For this particular problem, the u is going to be x and the v is going to be e to the x. Now before you get too excited about this, let's explain where the u and the v are coming from in terms of this product rule. So let's go on just for a sec here and take a look at the product rule where I have replaced the u, the f and the g with u and v. So instead of f, I've put a u up there. Instead of v, instead of g, I've put a v. So just hang with me for just a sec. I just need to do a little bit of algebra and calculus. And once again, this is one of my contractual obligations to my discipline. But you probably don't care about as much of this as I do. So I'm just like I did back here, I'm going to integrate everything, do the integral of all this stuff. I'll apply the fundamental theorem of calculus to the right side, or the left side, sorry. And then I'm going to rewrite these things in terms of, you know, derivative of u is du over dx, and derivative of v is dv over dx. And then I'm going to employ the chain rule again to get rid of the dx's, and I get this. One more thing, and then we'll have the integration by parts formula, and that's this right here. So the integration by parts formula is this. It might be a little bit easier, just a little bit, if I write it like this, so that here it is. All I've done there is I've switched the sides of the thing on the bottom. So if you need to write something down, which I know you all want to write something down, that's what you want to write down, is the integral of u dv is equal to u times v minus the integral of v du. I know it seems like we're going to take an integral and we're going to solve it by writing a new integral. Well, here's the thing about integration by parts, is we have an integral that's hard. So over here, usually what happens is this is hard, and this one is easy. Well, it might not be easy. It might be just easier. Yeah, so whenever I use something like that, so it could still be hard, but it's easier. We would hope that it's just easy, though. Okay, so let's go back and see how this works with this problem that I had right here. Can we use substitution? Why, no. But we can use integration by parts. So here's the way that you do integration by parts is we're going to take this, and I was a little bit disingenuous about my u and my v over here. That's correct. But in reality, here's the way that you do integration by parts. Is you look at this integral and you think about it as a product. This only works with products. You're going to group one of the two things. So you have a product of two things. One of those two things is going to get grouped with dx. The other one is going to be left all alone. So like I said, this is the correct way. I'll go back and show you how this relates to this u and this v over here. But now what you're going to do is you're going to write down u is equal to the thing that doesn't have dx next to it, and dv is the thing that does have the thing with dx next to it. And the reason for that is because I want this to look like this, u dv. So far, so good? All we're doing is basics. It's like a substitution. Okay, let me go back to my formula here. So my formula says that if you have the integral of u dv, I can rewrite this using u times v minus the integral of v du. Okay, so let's go back. I know there's a lot of moving parts here. We're going to practice this some. And if it takes us another day, that's fine, because I'd rather you feel good about this than feel angry about it. Okay, so I've got u and my v dv. So here's the way this how this shakes out, is I'm going to use the u and the dv to get du and v. I know it's still confusing, so many letters, but we're going to work through this with a number of examples. Zachary, what is the derivative of x? That's this u here. Whoops. So I want to know this derivative. Yeah, okay, very good. Yeah, the derivative of x is 1. But you've been trained now to, whenever you write the derivative du, you're going to write it as something times dx. So it is 1 times dx, which is just dx. Very nice. Okay, now we're going to do the antiderivative of v, or dv. So Allie, what is the antiderivative of e to the x? It's just e to the x, isn't it? So that's convenient. Okay, I'm gonna toggle back and forth just one more time here, because notice what I've done is I have this thing written as the integral of u times dv, and I need to remember what this formula is. Whoops, there it is. There's the formula. So let me write this down as u times v minus the integral of v du. Whenever I do this in class, and this is when I'm doing it in this class, in multivariable calculus, in Calc 2, anytime I do integration by parts, I always write the next line. You might get to the point where you don't have to, but I don't want to lose anyone or have anyone say that they don't know what's going on. So I always do this. And I know that you're going to get sick of writing that, so you might not write it, but that is the integration by parts formula. And so now what we're going to do is we're just going to rewrite the right-hand side there in terms of this stuff right here. So this stuff is going to get shoved into here. Okay, so let me just do it. I'm actually going to literally, oh, by the way, over here, you'll notice that those two are just the two things that I have on the left there. So the only disingenuous part about this thing is that I didn't show you the dv, so you don't know, where'd that come from. But anyway, so let's go ahead and write this. One other thing that I always do, and once again, you're going to think, why do you do this? It takes too much time. It's not worth it, but it's worth it to me, is I'm going to rewrite the left-hand side of this. So check it out. I have the integral of whatever u is. Well, u is x. So the integral of u, and then dv times e to the x dx. So that's the left-hand side. I always do that as a mental check to make sure that it's the same as what's up here. So I need to have that be the same as this. There's also another reason I do that, but that's like the advanced version of this. We're just doing the basic stuff, so hopefully we'll be okay. Okay, u times v. So notice I'm just going to pull this stuff from up here. I have x times e to the x minus the integral. I'm just doing the substitution directly. Everything is just getting substituted here, of v du. Okay, double check and see if everything, I can highlight if we need to, but you probably see where everything came from and where it all goes. If no one has any complaints about this, I'm going to go ahead and do the final step here. So the final step is to deal with that antiderivative of e to the x. So Thomas, what is the antiderivative of e to the x? It is just e to the x. And then, of course, now that we're done with all of our antiderivatives, I'm going to put a plus c here, and that is the answer. I think I've told you that when I was learning all this stuff, however many years ago it was, that I always found things like this to be so fantastical that I would have to try it, like check it. And you can check this. You can actually do the derivative of this. If you do the derivative of that, you actually get x e to the x. It seems, I mean, to me, I find it kind of amazing that that happens. Because you have two things here. There's only one thing up there. Why? Well, it's because some stuff cancels when you do the derivative of this. You can try it sometime for fun. I know you think that's not the thing that I would call fun. Well, you should get with the program and start having real fun. All right, do you have any questions about this? We got our u, v, dv, all this stuff. Okay, let's move on to a harder one. So let's try this one. So as you might guess, as we go through, things are going to get harder, but they're not going to be insurmountable. I have some examples that are insurmountable. We aren't going to do those. So we'll do this. This one's not too bad. So let me pick u, and I want dv. All right, let's go for this. Where are we on our list? Bryce, what would you like me to choose for u? I need a product. Do you see a product there, first of all?
I do.
Okay, what would you like u to be?
X squared.
Okay, that sounds pretty good to me. So what, oh, crud. Sorry about that. Come on. Sorry. Yeah, I need to, there we go. So what Bryce is seeing is he's seeing this product right here. Does that look good?
Yeah.
Okay, good. So if he's going to choose u equals x squared, then dv is equal to the natural log of x dx. So far, so good? We've got it separated. Everyone's cool with this? All right, let's go ahead and do the next step. The next step is to find du. Okay, who are we up to? Allison, what is the derivative of x squared? 2x, and of course, since we're doing a substitution, you're just going to tack a dx on there. So that looks beautiful. Now we have to find the antiderivative of the natural log of x. Okay, we're up to Elena. Do you know what the natural log, the antiderivative of natural log is?
Is it 1 over x?
That's the derivative of natural log. So we need the antiderivative of natural log. You know what? Does anyone know what the antiderivative of natural log? You know? Some number to the, no, it's not some number to the power of x. That's an interesting try, though.
Is it x to the power of 10?
No, because that's the antiderivative of 10x to the 9th. Yeah, this one, it has an antiderivative, but we don't know what it is right now. And so if you get to this stage, so this is why this one is a little harder than the last one. If you get to this point in a integration by parts problem, that you're integrating a product, then one of the things you could do is just swap the two things. So I kind of made, well, I don't know if I made him, but I kind of made this problem up so that Bryce would be most likely choose this for the U. So I appreciate you doing what I was hoping you would do.
Whatever I can do that.
Yeah, you're well, thank you so much. So here's how I could have written this so that I wouldn't lead Bryce astray. I could have written this problem like this. Put the natural log of x first, and then x squared next. Now, let's go ahead and redo this. So if you ever get to this point, and you're like, I can't go any further, then let's restart. I know it feels like a pain to have to restart, but it could be worse. If we get to the advanced versions of this, we'll see how worse it could get. All right, Elena, in this case, what would you like to use for u, and what would you, well, yeah, just tell me the u.
The natural logarithm of x, I forgot how to say it.
That's okay, it's fine. ln of x, you could just call it, if you don't remember. And then dv, of course, is the rest of the junk there. So it is helpful. You could have just done this from the get-go. For example, Bryce could have just said that he wanted the natural log of x to be u, and then I would have been sad, but I would have had to follow his instructions. If the natural log of x is u, then all the rest of the stuff is dv. But in this case, now we've got it arranged in a nice fashion. You can see here the product that I'm looking at, or that, was it Elena picked out for us? Now let's get our derivatives and our integrals. So what are we up to? Sienna, what's the derivative of natural log? Do you know?
1 over x.
It is. You're doing great. See how this is review for next week's test. So maybe I didn't lie. I'll have to go and review that video that we did. Did I take a video? I don't know. All right. Now I need to do the antiderivative of x squared dx. So who are we up to? Caitlin, do you know what the antiderivative of x squared is? Very nice. 1/3 x cubed. Ooh, I left off my dx over here, didn't I? Okay, does that all look correct so far? Okay, now, like I said, I always am going to write out the following. You don't have to, but it is helpful. So the integral of u dv is u times v minus the integral of v du. One of the reasons why I write that out, and well, one of the reasons is that I remember being told that I had to when I was learning this. Maybe I should make everyone do it, but it's kind of hard when you do your homework on Lumen. I have no idea what you're writing on your paper. At any rate, one of the reasons why I like it is because if you write it out enough times, you'll have it memorized. So write it each time you do this, and then at some point you'll say, I don't need to write this anymore because I am so sick of writing u times v minus the integral of v du. And you'll have it in your head, it'll be stuck there. Okay, but anyway, let's go ahead and I will arrange all of this stuff. So this becomes the integral of u dv. And remember, that left-hand side is always just a check to make sure that I've done things correctly. And then this is going to be the natural log of x, that's u, times v, minus the integral of v times du. I'll pause for a second. We'll see how we're doing. Wow, someone brought a new stapler? Where's my old stapler? Oh, there it is. I'll make sure I didn't. Oh, this one doesn't work. It's jammed. No, I've got mine with my name on it. I've had it in this room for a decade, I think. There we go. Okay, so let's see how we did. Hopefully you see what's going to happen here. So this is going to equal 1/3 x cubed ln of x minus the integral of 1/3 x squared. So do you see how the x and the x cubed, they combine to form x squared? So that's super important. That's what makes this one work, is because of that combination. Okay, now we just have to find the antiderivative of 1/3 x cubed. That's a polynomial, so I think you can do this. Kelsey, do you know what the antiderivative of 1/3 x cubed is?
X to the 3.
Almost. Let me just a sec.
Let's see.
Almost. Let me just a sec. Ln of x. Okay. So it is x to the third. So let's see. I'm going to keep the 1/3 around for a minute. So it's x to the third, but then what else do you need? So this 1/3 is just the same as that one. Times another 1/3, which I'm just going to write it as divide by 3. So I think you multiply it by 3 instead of dividing by 3. And then plus c. Very nice. So it ends up being x cubed over 9. I've run out of, oh no, I haven't run out of room. I can 1/3 x cubed this thing. Minus 1/9 x cubed plus c. Box it up. Apparently the AI wants us to put a smiley face, so we will. Beautiful. It's another one. I mean, I'm always amazed by the answers for these integration by parts problems. Let me zoom out, see if anyone has any complaints, concerns, worries, fears. Okay, I'm only going to do, so this is kind of like level 2. So just to show you where we are here, whoops, let me get this up here. So this one, I think of this one as kind of level 1. It's easiest. You just have your u and your v. It's all straightforward. Do it, done. The one we just did is kind of like level 2 because you have to rearrange a little bit. So you make a little rearrangement there, and then do your work. It works out pretty easily. There is one more level. I have to find it, though. I want to make sure I get it. That one's level 1. I know, you're looking at that thinking, well, there's a little bit of algebra to be done, but that one's easy. That one's easy. That's level 1 as well. Hold on a minute. Where's my level 2? That's like level 4. Okay, here. That one's extra hard. That one's extra hard. Okay, sorry. I just want to find a good. You know what? I'll just suck it up. I'll do this one. I just don't like that exponent there. I'm going to change this to x squared. You know what? I can just do this on my own right here. Okay, so this is kind of like level 3. This is as hard as things get. Let's do x cubed. Sine of 2x. Why not? So we'll do that. So you might ask me, why is this level 3? Doesn't look that hard, and it's not that bad. Let's go ahead and choose some u's and some v's. You can see it's a product that we have here. So I need to pick a u and a dv. Let's see. And as with the other one, remember we had one of them that didn't work out at first? If you get it wrong, we can just restart. So I don't care what you choose for your u. Zach, do you have something you'd like for u to be? All right, let's do sine of 2x, which means that dv is x cubed dx. So basically you pick something to be u, and then all the rest of the stuff gets into the dx column, or the dv column. Okay, we can do this. Not here, but Kelsey is. Kelsey, what's the derivative of 2x, or sine of 2x?
It would be 2 cosine of 2x.
Very nice. 2 cosine of 2x times dx. So here, you did a great job doing the chain rule on the fly without writing out your f and your g. That was beautiful. So if anyone's confused about where the 2 came from, it's because she did the derivative of sine, and then the derivative of 2x goes out front. Very nice. All right, dv is x cubed dx. So Thomas, what's the antiderivative of x cubed?
1/4.
That's perfect, x to the 4th. Okay, now I regret saying that I was going to do this every time, but I will. The integral of u dv, I'm sick of it already. uv minus the integral of v du. Okay, just a sec. Let me just put this down here. Okay. Yeah, we're going to use that one down there in a minute. I'll just get it out of the way though. Okay, so integral of u dv is the integral, I'm just pulling it right directly from all of these over here. So the u is sine of 2x, dv is x cubed dx. So I always make this check. Is that exactly what I was starting with? It is what I started with. So that's your first thing that you're going to do. Then you're going to write u times v. So, oh, duh. Sorry. I just noticed I had a dx here. Okay, so I do u times v. I'm pretty happy so far at your work. And then v du, 1/4 x to the 4th times 2 cosine of 2x dx. Okay, so let me just make a comment about this, what we just did here. Notice that when you did this particular integration by substitution, you started off with a polynomial. It's a polynomial, it's a monomial, but x cubed times the sine, which is bad because we don't know the antiderivative offhand. There's no substitution I can do. So that is my starting point. And then my next thing that I have to deal with is this. This is x to the 4th times cosine. I know there's a constant in there, but we're going from x cubed times sine to x to the 4th times cosine. I think, hopefully, you all see that we've made things worse. So if you make things worse, you want to roll back the clock, start again, and swap those two. So there's nothing wrong with what we just did. But just so you know, if you make a substitution that turns out doesn't work, it's nothing wrong with it unless you fake your way through this. So this is where you could make a mistake, is by thinking, oh, now I can just do this. No, you can't do that antiderivative, guaranteed. So that's why I wrote down this additional. I probably should just copied the whole thing and copied this. So I'll bet you can guess what the true substitution is going to be. So let's rewrite this. So let's try again. U dv. All right. So Allison, what do you think? What would you like the substitution to be? And you can't choose what Thomas chose, or whoever it was. Let's do that, u equals x cubed, because you only have a few options here. There's not a lot of choice. So you have this product. Either u is going to be x cubed, or u is going to be the sine of 2x. Sine of 2x didn't work out too well for us. This x cubed, it's not going to work out that great, but it's going to be better than what we have up there. So dv is sine of 2x dx. All right, now let's do our derivatives. Du, all right, Caitlin, do you have the, ooh, I've got 5 minutes. Do you have the derivative of x cubed? 3x squared dx, beautiful. All right, now this one's a little hard. Let's see if we can do it. Ethan, do you know what the antiderivative of sine of 2x is?
The antiderivative?
Mm-hmm.
Is that going to be negative cosine, or negative 2 cosine of 2x?
Negative cosine of 2x. And then there's going to be a number here, but it's not 2. No, don't worry about the plus c because we're doing integration by parts. It's actually 1/2.
Oh, okay.
Yeah, so this is what you're trying to do.
So is it negative?
It is yeah, it's negative because you're doing an antiderivative of sine. The antiderivative of sine is negative cosine, but then because it's not sine of x, it's sine of 2x, you have to deal with the chain rule. So technically I should have done integration by substitution to do this, but I don't want to have so many u's out there. I might have to have a double u. And I don't want 2 u's. All right, oh, it's almost done. We're going to do this. We're going to do this, don't worry. Okay, so let me write this out. There's my substitution there on the right. So this is the integral of u times dv. And this checks out. So you might get to the point where you don't want to write all that out. I can understand that. I don't want to either. Is u times v minus, so notice I'm just following the instructions up here. The integral of v times du. Let me clean this up just a minute, and then we'll be done. X squared. Whoops. Sorry. In my cleaning, I did not clean properly. There we go. Okay, let me just pause for a minute and say that's where we are. So there. So I just want to make sure that my substitutions, they all make sense. Now, what we might notice is you might say, well, that doesn't fix things. But it gets closer to fixing them. Notice what you're doing up here. In this substitution, when you go from here to here, things get worse. So things got worse down here. It's x to the 4th times cosine. Up there, it's x to the 3rd. Right here, as opposed to getting worse, we're getting better. I mean, it's not great, but this is better than what we started with. It's x squared instead of x cubed, so it's less complicated. Here's the thing that we're going to do next time, which is tomorrow, is we're going to do substitution a second time. Or not substitution, we're going to do integration by parts a second time, and I'll even tell you what the u is and what the dv is. Cosine 2x dx. So notice that when I do this particular integration by parts, I'll make things even better, because this thing keeps getting smaller. So you have x squared here, it'll be x to the 1st. But we'll do this tomorrow. I think that I don't want to have to split the homework. The homework has some stuff that's easy, like the first couple, and there's a couple of them that are like this, like level 3. So if you want to go ahead and do the level 1 stuff, you can, or if you don't want to, that's fine too, because I'm going to move that homework to be due on Wednesday. So see, we're slowly reviewing. We're doing review, aren't we? We're doing review. Derivatives, integrals. They're review for the final. It's good for us. So I'm going to stop the recording. If you want to come up and complain to me, go ahead and do your survey.